Imagine a moment when everything time, space, matter, and energy exploded into existence from a single, infinitely tiny point. Sounds like science fiction, right? But this is the real story of how our universe began, the Big Bang Theory. In this video, we're going to unravel the mind-blowing science behind the birth of everything, from the first fiery moments to the galaxies we see today. Buckle up. This is going to be a cosmic ride. Stick around as we break down the Big Bang Theory, explain why it's the best model we have for the universe's origin, and explore what it means for our place in the cosmos. Let's dive in. So, what exactly is the Big Bang Theory? It's not just a TV show. It's the leading scientific explanation for how our universe began about 13.8 billion years ago. Picture this. All the matter and energy in the universe was once compressed into an incredibly hot, dense point, smaller than an atom. Then, in a fraction of a second, it exploded, expanding rapidly and creating space, time, and the building blocks of everything we know. But here's the kicker. It wasn't an explosion in space. It was the expansion of space itself. This idea was first proposed in the 1920s by scientists like Georges Lemaitre, who suggested the universe started as a primeval atom. But how do we know this actually happened? Let's look at the evidence. The Big Bang isn't just a wild guess. It's backed by solid evidence. First up, the universe is expanding. In the 1920s, Edwin Hubble discovered that galaxies are moving away from us in every direction, like dots on a stretching balloon. This redshift of light from distant galaxies suggests the universe was once much smaller. Second, we have the cosmic microwave background, or CMB. This is like a snapshot of the universe when it was just 380,000 years old. A faint glow of radiation from the Big Bang's afterglow, discovered by accident in 1965 by Arno Penzias and Robert Wilson. The CMB is everywhere, and its temperature matches exactly what we'd expect from a hot, dense, early universe. Finally, the abundance of light elements like hydrogen and helium. The Big Bang Theory predicts that the early universe's intense heat fused protons and neutrons into these elements in precise ratios. When we measure the universe today, those ratios match perfectly. It's like the universe left us a cosmic recipe. Let's walk through the Big Bang's timeline. Buckle up. It's fast. At time zero, the universe is an infinitely dense, hot point. We don't fully understand this moment, but here's what happens next. Planck epoch 0 to 10 superscript 3 seconds. In this unimaginably tiny fraction of a second, all the fundamental forces, gravity, electromagnetism, and the nuclear forces were unified. We're still trying to crack the physics here. Inflation, 10 superscript 3 to 10 superscript 3 superscript 2 seconds. The universe undergoes a mind-boggling growth spurt called inflation, expanding faster than the speed of light. This smooths out any wrinkles and sets the stage for structure formation. Formation of particles, 10 seconds to 3 minutes. As the universe cools, quarks and gluons combine to form protons and neutrons. By 3 minutes, nuclear fusion creates hydrogen and helium, the seeds of future stars. Recombination, 380,000 years. The universe cools enough for electrons to pair with nuclei, forming neutral atoms. Light can now travel freely, creating the cosmic microwave background we detect today. Star and galaxy formation, 100 million years onward. Gravity pulls matter together, forming the first stars and galaxies. Over billions of years, these build the cosmic web of galaxies we see today. Let's clear up some myths about the Big Bang. First, it wasn't a typical explosion with a center. It happened everywhere at once because it was the expansion of space itself. Second, the Big Bang doesn't explain what caused it or what came before. That's still a mystery, and scientists are exploring ideas like quantum fluctuations or multiverses. Finally, the Big Bang isn't done. The universe is still expanding, and we're living in its ongoing story. Why should we care about the Big Bang? It's not just about the past. It's about understanding our place in the universe. The Big Bang Theory explains how the elements in your body were forged in the hearts of ancient stars. It helps us predict the universe's future. Will it keep expanding forever, or collapse back on itself? Plus, it drives cutting-edge science, from particle accelerators to telescopes like the James Webb, pushing the boundaries of what we believe is possible. Every discovery about the Big Bang brings us closer to answering the ultimate question. Why is there something rather than nothing? And that's the Big Bang Theory, from a single point to the vast, beautiful universe we call home. It's a story of creation that's still unfolding. If you love this cosmic journey, give this video a thumbs up and subscribe for more scientific adventures.